Hello everyone. In the previous video we were talking about the temperature and how to measure the temperature. We have mentioned that there are three common temperature scales and they are all measure the average kinetic energy of particles. It's very important because we're talking about the temperature. All of them, they are measuring what? The average kinetic energy of particles. We have mentioned these scales. What are these scales? Celsius, Fahrenheit and Kelvin. We have mentioned in Celsius and Fahrenheit scales, temperature is measured in units called degree. Just to remind you about these main points, and you have to write these main points. Degrees, and you can see this small circle or zero above the C or F, okay, are equally spaced unit between 2 points. The space between degrees can vary from one scale to another. They are not the same. In the Kelvin scale, no degree sign is used. The unit is just called a Kelvin. Okay. Temperature is measured, as we mentioned, by using a thermometer. The Celsius scale is the temperature scale most commonly used around the world, which is the most commonly used. How is temperature? And the Fahrenheit is used most commonly in the United States, as we mentioned. The Kelvin scale is used most commonly by physicists, for physicists and their experiments. And if you are reading like a physics book, you will find they are using most likely what a Kelvin scale. Okay, and don't forget the absolute zero. I'm going to ask like different questions, and we want to solve different questions together to make sure that we understand the lesson. Let's look at this question first.
According to the kinetic theory of matter, particles of matter are always in motion. Match each term to the correct image showing that state of matter and its particle movement.
Okay, let's start with the first one, this one here. Look how the particles, they are not very apart from each other, but still they are apart. So these particles are here. Let's look at them. Liquid. Okay, the second one here, look how they are apart from each other and they are moving. Look how these represent the movement of particles. They are moving freely, so they are gas. This one, the last one, they are attracted to each other, or they are close to each other. So so this is the solid.
The image on the left shows a liquid. The image in the middle shows a gas. The image on the right shows a solid.
Let's continue solving like these questions.
The two teas in these pictures, while they might be equally tasty, are at different temperatures. How does the hot tea differ from the iced tea? Click all answers that are correct, then click OK.
Okay, let's see what are the answers are correct. Maybe one, maybe two, maybe all of them, maybe only one. Let's see. How the iced tea differ from the hot tea? The temperature is higher in the hot, do you think? Let's see, maybe. The average kinetic energy of particles is higher in the hot tea. What do you think? The particles are more attracted to each other in hot. The particles are moving faster. Let's see. Look at the first one. Is the temperature gonna be higher in hot tea? Maybe. The average kinetic energy of the particles is higher, and if you want to measure the temperature for this one or this one, the tea or hot, is the hot higher temperature? Maybe. The particles are more attracted to each other. Do you think so for the hot tea? Actually, I don't think so. The particles are moving faster for sure. So these are the three answers are correct, but the third one is not. Let's see.
Correct. In the hot tea, the average kinetic energy of the particles is higher. Therefore, the hot tea's particles are moving faster and its temperature is higher. It's not the case that the hot tea's particles are more attracted to each other.
Okay, so this is the question here. Let's look at the question on your book, which is on page 116. And you have another question on page 117. I want to answer with you question 7 and the question 9. for question 7, explain how does a substance's temperature change when the average kinetic energy of its particle increases when it decreases. What do you think? What do you think? So here, if we're talking temperature increases, the temperature, let's look at it again for question 7 to explain it. How does substance temperature change when the average kinetic energy of its particle increase? It's gonna what? The average, it will increase. What about in when it decrease? The temperature what? It also decrease. So this is the answer. Let's move to talk about question 9. What is body temperature in the Celsius scale and the Fahrenheit scale and Kelvin scale? In Celsius, if you look at your book, page 117, the normal body temperature, which is 37, equals what? 98.6 Fahrenheit degrees, and in Kelvin equals 310 Kelvin. Okay, so copy the answers. These are the answers. Copy the answer. No, not this one. Only 7 and 9. Okay. Now I'm going to make like this virtual lab with you. I want you to write all the steps I'm doing and to answer the questions that I'm asking you during this virtual lab. And after you finish from this virtual lab, you can write your conclusion from your observation. Let's start together.
Here are 2 beakers of
listen carefully to her. She's mentioning what do we have and what we are going to do, and I'm going to explain again what she's doing. Listen carefully. She mentioned you have here like 2 beakers of water. Look at it and listen carefully.
Water. You can see that one has a temperature of 10 degrees Celsius and the other has a temperature of 70 degrees Celsius. If you were to mix the contents of the beakers, what would you expect the temperature of the resulting water to be? Okay. Follow the instructions to see what happens.
Listen carefully. Here you have 2 beakers. Beaker number 1, beaker number 2. Both of them, they have water. Both of them, they have the same amount of water. Put it in your mind here, as you see. One of them, it has the temperature. They use the Celsius scale, as you see, which is here Celsius C. Okay, they measure the temperature for the first beaker, which is 10 Celsius degree, and for the second one, they found it 70 Celsius degree. The experiment here, she wanted to mix these 2 waters together from beaker number 1 and beaker number 2, and we want to see what's gonna happen to the temperature. It's gonna stay, what is the temperature will be expected now. You have to put your prediction. What do you think if I mix these 2 water together? What do you think gonna happen? Okay?
Drag the thermometer to remove it from this beaker.
The first step, I'm going to remove this thermometer.
Drag this beaker to the other beaker to mix their contents.
I'm going to add this water to beaker number 2. Water in beaker number 2, look.
Watch the thermometer. Was the result what you expected?
What is the temperature now after we mixed these 2, which is 40, as you see here, which is 40 Celsius degree, as you see. The temperature here, it has been what? Decreased, sorry, as you see for this beaker. Okay, this is the thing that you expected. Is your prediction correct? You have to ask yourself. Let's look here why it's 40. Let's look and listen to her.
In the previous experiment, you mixed samples of water that had temperatures of 10 degrees Celsius and 70 degrees Celsius. Why was the final temperature of the mixed water between 10 degrees Celsius and 70 degrees Celsius? Click the correct answer and then click OK.
Look at these 2 choices. You have energy was transferred from the water at the lower temperature to at the higher temperature, or energy was transferred from the water at the higher temperature to at the lower temperature. What do you think? From hot to cold, or from cold to hot? For sure, This is the correct answer. Let's see.
You got it. The water at the higher temperature contained more energy. Energy in the form of heat is transferred from objects at higher temperatures to those at lower temperatures. So, when the water samples were mixed, some energy was transferred from the hotter water molecules to the colder water molecules until all molecules had roughly similar amounts of energy.
So you have to write this note and the explanation for this answer. You have to write it down and you have to memorize. These points are very important. Okay? This is all for today. If you have any question, you can send me your question. Thank you for listening.